Hi, everyone. Thanks for joining us. I hope you can hear us loud and clear. My name is Josh Hiroko. I'm going to be facilitating this session. Here with me, we have two titans. Their bios are extensive. We tried to summarize it for, for this session, but I'll allow them to introduce themselves in their words. Imran?
Hi, Josh. Thanks for that. Imran Khan. I'm responsible for the digital experience at TD Bank, and we're starting to do a lot of work on the AI side. So I'm really excited about this session. I also run our accelerator, an incubator and accelerator for TD Bank, which is called Yugo. And Yugo is a startup company that we recently fully acquired. So excited to talk to you about some of the use cases that we're applying in this field today.
Awesome.
And I'm Jonathan Smith. I'm a machine learning scientist at LayerSix, which is TD Bank's internal artificial intelligence lab. And we work on use cases applying artificial intelligence within TD Bank and in external partnerships with research communities in Toronto and around the world.
Fantastic. As I said, these guys are very talented in their field, and that's what we want to learn from them. But before that, we jump in. I have a trick question to ask just to warm us up. If you were to be a box of cereal, what would be your preference?
Great question. Maybe I'll go first. And I would say Fruit Loops, just because my kids love Fruit Loops, and they're getting to that age where they don't like me as much. So I would want to be Fruit Loops just so that I could get back on the good side with my kids.
Gotcha.
I think I'd want to be Lucky Charms. I mean, there's just something wonderfully creative about all the images and colors inside of it.
Gotcha. So now we know them a little bit better. Diving in deep a little bit into this, it's meant to be a session where we sort of look at business layer applications of artificial intelligence in a real world scenario, but at the same time, dig a little bit deeper. And that's where the focus of the masterclasses really is. And we're really welcoming you to what is going to be month by month, going in deep into particular topics, talking to industry leaders who would share their view on a business level layer, but as well as on a technical level layer. We found that a lot of folks are more getting interested in getting into specific spaces and understanding how this works with individuals who work in those spaces right now. Tremendous. It's just going to be tremendous. Again, Imran and Jonathan, thank you for taking the time to be with us. A lot of things that we're going to go through, we might sort of mask some intellectual property if they would discuss about that. So just bear in mind that a lot of the use cases might be examples, and some of the use cases might actually be real world scenarios that you've dealt with, on your day-to-day basis. Without further ado, I would say that we pass it off and start the presentation.
Thanks a lot, Josh. I wanted to quickly kick off and talk a little bit about something that we're working on at TD. And in that context, one of the most important things that we found when it comes to new technology capability, and AI is no different, is that it's really important to be careful not to do AI for the sake of AI. You really want to make sure you're looking at solving problems, and there's a problem for your organization that you're looking to solve, and that AI is a good fit to solve that problem. And we had to look, we had to be very careful with that, because it's easy to get enamored with something new and kind of fall into that trap. So one example that we recently talked about, externally is a project we're calling MyTD. And that's really about authentically, advising our customers through our digital applications. And, one way that we can do that is, in this world, what we're seeing a lot of, certainly across Canada, across North America, and broadly is it's becoming more and more difficult to manage cash flow. We have a situation where, people are, living paycheck to paycheck. And if your pay is delayed by a week, that could result in, challenges. And so we really wanted to help those customers. And we felt like predicting cash flow would really empower and enable us to do that. And it was a great use case for AI because it's, sufficiently complex. And, we went down that path, and that's something we're working on right now. And we're really excited about being able to deliver that, that initiative to our customers. And quite frankly, there's many different use cases that can come out of just that, even that one model. And so we're very excited about that case study that we're working on with LayerSix. I wanted to just touch upon, quickly, just a couple of external examples that I thought were really good to help highlight, some of the things that from a business lens, you really want to think about as you explore a technology like this. A great example that someone shared with me a couple of years back was, was an example out of Tesla. A few years ago, someone that I know who's really well known in Silicon Valley had, he was, had run AI companies, was trying to make his teenager a believer in AI and as a capability, and his teenager was very skeptical about it in terms of what it could deliver and whether or not it really could produce outcomes, for example, autonomous cars. He said, that's a long time away. I don't see that happening anytime soon. So one day, he took his son in his Tesla, and there was a little curb in the front, and he took his hand off the wheels, and of course the Tesla took over and drove around the curb. This was a feature that was that he downloaded the night before, and personally I wouldn't take that risk, but as you can see, the adoption of these types of technologies and the pace of adoption is greater than ever before. And it isn't just about the model, it's about building the whole ecosystem. Think about the testing, the quality assurance that needs to happen to support this. Think about all the other systems, running at the edge, whatever that edge device might be. In this case, it's a car, it could be something else. They need to support, that experience. And that's really, really important. And, our learning from the application of AI that we've had is that you've got to make sure everything around the model is there to support the right outcome, and the technology around it is so important. And please don't lose sight of that, because that is critical. One last example, I thought I'd share before we go deeper into how we're using AI and what it is. It was an example that many of you may be familiar with. It's the Alphago example. And Go is a game that's very, very complex, and many experts thought it would take 100 years, if not more, for an AI system to defeat a top Go player. As you guys have probably heard, that happened very, very quickly, much more quickly. Maybe in a couple of years, DeepMind, which is a lab that Google had acquired, was able to develop Alphago, which defeated the best Go player in the world, just barely 3-2, but it learned from other Go players, and it, defeated this Go player. What a lot of people don't know is that, the same company developed AlphaGo Zero, which was developed by playing against itself. So it never played any humans, it just played against itself. And it developed techniques that were never before developed. And they played AlphaGo Zero against AlphaGo, and it won 100 out of 100 matches. And so again, the pace at which these technologies and this capability can evolve is quite dramatic, and it's something to think about. One related fact around that is that Google actually ended up using, the AlphaGo capability. The first public use case that they shared was actually, the cooling of their data centers. Not the coolest thing, but huge value and very high value for them. And that's something from a TD perspective that we are also doing. We have many use cases that, we can highlight externally, but there's many use cases that aren't the coolest use cases in the world, but are extremely high value, that are coming out of our capability at LayerSix. And I'd like to pass it over to Jonathan, but before I do that, I just wanted to introduce LayerSix a little bit. TD had acquired LayerSix a couple of years ago, and LayerSix, the last 2 years has won, what I like to refer to as the Oscars of recommender systems, defeating some of the top companies on the planet. And they had won twice, by a good margin on the first one, and the second one by a decent margin as well. So very strong capability from a machine learning perspective. And I've asked Jonathan to walk us through in more depth some of the things that we're doing to apply the AI at TD and provide a primer on AI. Jonathan is a machine learning scientist at LayerSix. So over to you, Jonathan.
All right.
Just before you take it over, Jonathan, I just had a few quick nuggets there, and I'm going to reverse back on Imran a little bit here. But before that, please fill the Q&A box. It's there for you to ask every kind of question that you want. We have questions coming in already. There's a not to steal any thunder, there's over 100 folks already on the call. And so we want to see your questions. We have these folks here for this time period to ask them specific questions and put them on the hot seat, and let's hear what they have to say. Another thing that I would like to pass across is there would be a recording of this as well on an LMS that you can access afterwards. So if you wanted to replay this back again so they can get some concepts, happy to provide you with that after the session. Imran, before Jonathan jumps on, I wanted you to just walk back slightly on your educational background, just to get an idea, because some folks on the call are not ML or AI focused right now, and they probably have possibilities of doing that, or some are and are looking to further their career. Just walk us through in a couple of lines how you got to where you are.
Absolutely. Great question, Josh. And my background, I was a computer engineer by education, and I always loved technology, and to this day I still have a very strong passion to go deep into technology. I also have an MBA, so I wanted to kind of enhance my technical background with an MBA and kind of further my career within the technology space still. But I found the MBA really helped. What I would say is a lot of folks have technical backgrounds. Obviously, if you're going into this field, what I've found: computer science, engineering backgrounds, that sort of thing. There's more specialized programs coming up. But what I would say is there's also a lot of related fields. We have folks that have backgrounds in psychology, backgrounds in anthropology, backgrounds, all kinds of different backgrounds that support us with things like, understanding what are the implications for consumers, what are the implications for people, supporting us with helping, train these systems. We have people that really understand these things. And so there's so many different varieties of ways that you can be engaged when it comes to, artificial intelligence. You don't have to be, a machine learning scientist or a data scientist to be engaged. And I'd encourage you guys to, to look at some of those evolving types of roles that are coming up. And we're certainly seeing, more and more of that type of thing. And technology, is a broad space. You still need quality assurance. You still need resilient system stability. All of those things matter, if not even more so now, because the engagement is going to skyrocket, we believe, with AI first sort of coming into place, certainly for us at TD Bank.
Yeah, that's good. And in terms of diving deeper, especially brought in the perspectives of folks who are working with AI and ML, Jonathan's going to go in section 3, just talking about challenges and fairness as it regards to that. So that's going to be covered for sure. You already answered one question I was going to ask you regarding some of your favorite AI use cases. Probably answered more than I would have needed to. But one other question that I had was around justification on a business standpoint as to the investment for AI. So you mentioned the acquisition of LayerSix, for example. You also mentioned the acquisition of Hugo. You also mentioned the app that's currently ongoing. If you look at the app, the acquisition is a big money moves. What can you drop in terms of nuggets that folks who are, senior managers right now pushing the envelope on advancing tech adoption within their environment can use in terms of supporting their business cases for these exercises?
Yeah, great. Another great question, Josh. And a couple of things I would say. One is there's a lot of energy and excitement around innovation, and artificial intelligence plays a big role in that. And you want to take advantage of that, but do it in the right way. Make sure you're solving a problem. You don't want to do it just for the sake of doing it. If you can solve a real world problem and demonstrate that benefit, many leaders today have a keen interest in applying these new technologies, and they're looking for their teams to find ways that those technologies can drive value for the organization. And so you really got to make that connection. That's really, really important in terms of selling this back. Personally, some of the things that we did that worked well, we tried to start small. So we tried to kind of keep it, we didn't want to come in with this big investment that's required to build this out. We wanted to make sure we're testing and learning. And so we're starting small, we're getting things out to consumers, we're learning, using that feedback and kind of then expanding the use cases once we've validated that we can get the value that we think we can get. And so that helped us quite a bit. You know, and personally, you know, my style of working is, you know, don't make it too big before you're ready. You know, that's the other thing about starting small is you don't want, especially in a larger organization, what I find is, you know, you don't want too much of a spotlight on you until, you know, you've built enough of a capability and you've got enough proof points behind you that you know it's going to succeed, because sometimes just the weight of that spotlight can be difficult to navigate in a big matrix organization.
Awesome. And just before I pass it to Jonathan, we were discussing and doing the scoping, and we were talking about how technical do we want to go. Folks are asking about data schemas already. So keep in mind that, you know, folks are really curious about this and want you to go as, you know, flexible as possible. Also, guys, please, you know, engage online, hashtag BPTN. You have this as an opportunity to share what you're learning with your community, both online and on every platform that you have. So Jonathan, I'll pass it over to you to give us some more in terms of a deep dive.
Okay. So we'll take a look next at machine learning in general and what we can learn about it and what we've learned about it at LayerSix and at TD. We take a look at machine learning in terms of the whole kind of pipeline of things. And if we could get the next slide and the next one, we kind of take a look at the whole kind of system. And we think about it in terms of a couple of different things. So first, we take a look at what kind of problem we're trying to solve. And so Imran's discussed a few of the use cases that we're dealing with at LayerSix and at TD. And that always starts with us getting the business case together for the problem and understanding what we're trying to do. So in machine learning, you might have heard of terms like classification or regression. These are supervised learning problems. And this is an overall kind of way of systematizing how we approach a problem, where we're either trying to classify some set of inputs into a few labels that we've attached to those inputs, or we're trying to use regression to determine where in some continuous space the final output or prediction should land. And we do that by looking at a bunch of historical data. Instead of applying a bunch of rules that are specific if-then statements, we try to show a machine learning model all of the examples that we have of a certain problem, whether it's classification, regression, or other problems. And then we use that data to understand the overall structure of the problem and to determine what the output should be. And what this means is a lot of increased complexity. So when you're looking at the system diagram that we've kind of put together there, you can see that there's lots of opportunities for bias, for problems, due to the different ways that we collect data, the different ways that we test our systems, and the different ways that the output goes to the final user. And these are all things that we have to consider when we're building our own models and thinking about the potential impact on people. So a couple of things there. First, you look at the data that exists in the world. We look at within the bank, information that we have on customers and information that we have externally as well that we can use. And then we look at the problems and who is specifically affected by those problems, whether it's something like balance prediction or something like understanding who's interested in getting a mortgage. And we determine what data we need that best represents the users we'll be creating a prediction for. And we select that data. And that selection process is one that we have to go through carefully to make sure that we're selecting correct data and that we're following the right schemas and that our databases are all aligned. And within a large organization, there can be a lot of challenges for those of you that are working within organizations with lots of legacy systems. This is a big area for improvement and understanding what's going on. Once you have that data, then you can measure it. You can select the features that are most important, and you can split it into what we usually refer to as a training set and a test set or an evaluation set. And these benchmarks help us to understand the performance of our models without leaking information back into them. And so we train on a training set, we determine what the model should look like in terms of its output predictions, and we're able to evaluate that against other models that might be simpler. Machine learning is not the only way to solve a problem. Sometimes it's as simple as writing one if statement, and that can be more effective in the long run than a large, complex machine learning system. But often we find that actually the use cases we apply machine learning to benefit a lot from the increased complexity of these models, because they can capture a lot of things that are harder to capture with simpler models.
Can you explain just a couple of examples about those kind of use cases in relation to that diagram and the stage you just got to?
Yeah, so a good example of this would be like mortgage prediction. We predict whether or not someone might be interested in the future in a mortgage, and we would select information related to whatever information we have at the bank maybe, or external information about trends in the marketplace. And we can put all of that information into a system, splitting it up into a test and training set. And we pass every example of the training set through our model. And I'm being vague about what the model is, because part of the idea of machine learning is that you try out a bunch of different models, and you try to figure out what is the most effective model for the use case that you're building. And different kinds of use cases will benefit from different forms of machine learning. And I'll explain a little bit about some of the industry methods that we use, gradient boosting and computer vision problems and natural language problems where we use more deep learning, which are kind of the sexy things that everybody likes to hear about. And once we've tried that out and we've seen how it performs, often against maybe human intuition, we'll talk to people within an organization like TD, and we'll say, hey, what do you think of these examples? And how have you been predicting, or how do you go about currently determining who you want to send information about a mortgage to? And then we can benchmark against that, and we can determine whether or not our models are adding value or not. And often we find they are, which is great. And then we will slowly roll them into production, which is that last part of the system where we talk about model output and the real world implications. And that's where you also need to think beyond just the code that you're writing or the data that you're analyzing, to think what happens once the information that you're generating through these models starts going back into the world, and you take action based on a prediction, or you make a decision as an executive or as a leader within an organization based on a model that has been generated. You need to understand how that decision affects the data that you are then using in the model on a continuing basis. So that's kind of like a high level overview of maybe our approach to machine learning, and maybe I can dive into some of the more specific models.
Yes, please. And before you do that, I know that you have a couple of links at the end of the slide just for folks that, if you wanted to interact with, but we're beginning to have some questions around if I wanted to, make use of the models that are available publicly. You have, the beast that is TD to be able to gather data. Where can I go to find sample training data, or like to start to work on data schemas if I'm just like starting to get into the space?
Oh, that's a great question. And I will address some of those along the way maybe. Nice. and provide some links. So let's see what we've got for the next slide. So we'll start off by talking about gradient boosting method. So this is this is one of the industry standards that we use for determining often classification problems. And this slide might look scary, but there's actually, I'll try to systematically work through it. And there's some great resources. There's links at the bottom of the slide that you guys could go to and play around with stuff. But also there's lots of reading online if you just Google like gradient boosting methods that will give you information. And maybe you've heard of sort of the predecessor of gradient boosting, which is the lovely decision tree. The decision tree, I think, is fairly commonly known within statistics, where you have a data set and you split at each part in the tree based on the way that you can maximize the information that you have left within the data set. And then you can classify by looking at a given example and all of its attributes where it should end up in the classification chart. So in the example on the slide, there's a two-dimensional box where the inputs would be the X and Y coordinates of each item, and then there's a classification applied of circles and squares. And so this is a binary classification problem, and a simple decision tree might look at the X variable and decide that any input that has x less than 1 is a circle. And as we can see on the slide, that's true. But it's not true that any x greater or equal to 1 is a circle. If you just take the most popular classification, it would be a square. But that leaves some error in the model. And so in a regular decision tree, you might try to get rid of this error by just adding more nodes and making it a deeper tree. But this can lead to lots of variance or high bias in the model, depending on the way the classification in the given data set is unbalanced. So there's maybe a lot more squares than circles, and then it'll be more often predicting a square, which leads to higher performance, but less good performance for the circles. So we try some other things like random forests, which is kind of the next step after decision trees, where you grow multiple trees and each tree tries to maximize its performance in a slightly different way, and you take the average of all the trees, and that leads to your final prediction. And then gradient boosting is a step beyond that, where each tree that you grow is simple and usually smaller than a regular decision tree, but the next tree always trains on the error of the last tree. And what that means is that you can minimize the problematic parts of your data set or your model and improve the overall accuracy a lot. And what you see in the right image is, again, a similar data set where there's an X and a Y axis and there's points within it, and each point is given a classification. And using a gradient boosting tree, you learn over like 150 different trees how to classify which points are orange and which ones are blue. And this is actually a very difficult data set because it's nonlinear and there's not like a single line that you can use to split through everything because it kind of spirals around. And so it's a good benchmark to see how well gradient boosting methods perform. And on the right, you can see each individual tree and how it splits. Even though each tree isn't as complex, the overall model is able to define the complex decision boundaries, which is really exciting. And gradient boosting methods are very high performers. We use them within the bank and in lots of external use cases as well, and have found them to be very helpful in a lot of different situations. We use them with balance prediction. We use them with other use cases. And there's just a lot of benefit to have from learning about these. And this is definitely something I would encourage you to learn about if you're interested in understanding more of the model methodology and trying to understand what is used in industry. There's lots of competitions that are freely available, especially Kaggle is a great website and resource where you can go and get free data sets and challenges that will evaluate your performance of your model, and you can build the model and test it out against hundreds of other people around the world and see how you do. And when you're trying to learn these things from scratch, there's obviously great resources online as well. Coursera has great ML resources, Fast AI. I think I linked to those at the end. But these all help you to understand some of these industry methods that we use.
That's an interesting sort of walkthrough in terms of application and use of this particular method. A couple of concerns maybe, and you could address this again because of your viewpoint around redlining in terms of certain services that are provided by maybe a bank or a financial institution. So you'd mentioned mortgages, for example. It's a popular service. A lot of people would need it or use it right now. How do you go about combating redlining where it doesn't sort of reduce the possibilities of favorable services being provided to certain communities, certain areas, and so on?
Yeah, so we do a lot of work to consider like the complexity of our systems and the fairness of our systems. And so we measure a lot of metrics in terms of the unbalance or the balance of our data sets. And one of the things that we like about gradient boosting methods is that they're built specifically to reduce variance in cases where your data set is unbalanced. So if you have a lot of people of a certain age and not a lot of examples of an older age or a younger age, you can still fairly accurately predict something. We also are careful about like where we're using our models. We have internal tools that we've built to consider the fairness of our models. And we have within the bank a lot of risk management processes that are highly regulated actually. And something that I find really great about working in the Canadian regulatory environment is that we care a lot about the impact of our models on end users, and that goes everywhere within the bank and externally as well. So that we're very, very cautious about these kinds of examples that you're taking.
Yeah, and our control environment would support, you know, in the same way it would support any kind of initiative and decision. You know, I can say certainly our control partners and risk partners are very, very deep into these materials, and they're, you know, they help sort of guide the team so that, you know, we make the right decisions in terms of when we apply a model, how we use it, and ensuring that really, you know, fairness across the board, you know, aligned to, you know, the TD culture and TD's guiding principles.
We also work with external researchers. So we have at LayerSix, we have a close partnership with the Vector Institute, which is one of Toronto's leading AI research institutes. And we work with members there who are very focused on fairness and understanding that within machine learning methods, which is really great to be able to work alongside academic research who maybe have different incentives in the work that they're doing, but that we can then apply it. And work together to give examples to them as well.
And we see, you know, the TD is, we tend to be more cautious, you know, we're known for that. And, you know, what that allows us to do is we can learn from others, you know, we can learn from other examples. And we've certainly seen examples of, you know, problems in terms of how these models have been applied. And you know, we're very careful to learn from those examples so that, you know, we don't make those same mistakes.
Yeah, that's really great, especially the example you give about working with academic researchers, because from their standpoint, they're usually not profit oriented, or usually not, you know, answering to a particular call in terms of a business, but more understanding where this can be well-rounded in terms of providing services to individuals. Digging a bit more on services, TD is a huge bank across multiple locations. How would you say you have been involved so far in helping out regions and municipalities sort of understand how they can use AI in terms of moving forward certain services that they provide, in terms of if they've asked you guys for help, or if they've asked you guys for support, or if you just provided resources to them, or if this is something that you haven't done yet, but you could be looking to us doing in the future? What does that kind of look like right now?
Yeah, so I mean, we've you know, I can talk, and Jonathan can share some specifics as well, but we've certainly looked at using our capabilities, you know, we've in many different ways. You know, I'll share an example. It's not necessarily AI specific, but certainly related to AI. You know, we started a program for patents for startups. So if anybody out there has a, you know, startup company, you know, a lot of times you're bootstrapping it, you know, maybe you're starting a new company and you're learning about AI and you want to get into this space. What we've done is we've said, hey, look, you know, it's expensive to file a patent, you know, so we'll support you through that process, and you know, we'll actually fund that so you can protect your IP, you know, and you may have developed, you know, any kind of IP, some kind of utility patent, maybe a new kind of model, whatever it is. And you know, what we've said is we're going to go out and support some of these startup companies by helping spur more innovation. So that's one thing we've done. LayerSix has been involved in the community on the LayerSix side to help solve complex problems, working with you know, community leaders, working you know, with the government of Canada as well on several initiatives, so that we're using our capability not just to support the bank and the bank's objectives, but to support our broader objectives, which is to serve our colleagues, our customers, and our communities. And so giving back to our communities, which is really, really important for us, especially given how embedded and immersed we are within the communities that we serve.
Gotcha.
So maybe I can give some examples of things that LayerSix is doing on the deep, like, neural network side, just to, like, also take it back technical, because I love talking about the networks and stuff. One of the things that we do is we work with Ontario Health Services, and OHIP and these groups to think about the ways that we can use population health data to better predict patient outcomes. And so this is like an external research opportunity for us, but one that the bank encourages because they want to see our community thriving. And it's a really great application of some of our deep learning technologies. So deep neural nets are a bit different than gradient boosting machines because instead of taking one example and charting a path through a tree with it, you instead affect the whole model with every example that you create. And you pass the inputs through, and each node in a network then sends on some information to the next set of nodes, which is called a layer. And you pass it all the way through, and you create a prediction or a classification at the end, and you check it against the result. And if it's not the correct result, it then reverses or back propagates the information that it gained from having that incorrect result or the correct result, and helps reinforce the weights in a way that causes the network to generate a correct prediction in the future or to improve it. And these are very data intensive models, and they require a lot of information. That's why they're very practical for examples like computer vision. We recently built a model that could predict pneumonia within x-rays of a chest image. And that is like very high density information, these large x-ray scans, and requires large networks in order to better predict. And we do that in collaboration with radiologists who label images and show us where they do see pneumonia and where they don't see it. And we use all those examples. So that was a successful kind of external research opportunity. And we also do the same thing with natural language processing, where we look at large amounts of text, and then we're able to understand like the structure of the text. And we do work in that area also with external researchers. So that's a lot of fun for us, but it's also really important to us because if we want to both benefit the bank's customers and other people, we need to work outside of the bank as well. So we develop these opportunities. We work on things like predicting diabetes and complications from diabetes with doctors. And then we are able to bring those similar models back to the bank and say, oh, maybe there's a use case within our organization that we can also apply it. And as a whole, the whole bank is interested in applying AI. It's not just one division. It's not just in digital. It's not just in apps. It's across the bank. And it's a huge like collaborative effort.
Yeah. That's pretty good. Go ahead.
It's a great point that Jonathan made as well about, just the enjoyment of what you work on, and, the talent that we're hiring, whether it's data scientists, designers, all the different fields that we're looking at. One of the things that's a common thread is they want to work on impactful projects. They want to work on things where they're making a difference in the communities and, across the country and globally. They want to work on innovative things that are going to have an impact. And that plays a big role in our ability to attract and retain talent, whether it's within LayerSix or the broader organization at the bank. So some of the initiatives that Jonathan talked about are really important for us in that way too. Not only does it allow us to give back, but it allows us to attract and retain the best possible talent as well.
If you guys heard LayerSix and TD is hiring, that's just basically what he said. You had mentioned a site that folks can go to. I think there's a spelling that they would like. Is it Toggle? Is it Kaggle? You mentioned a site.
Kaggle is a website for machine learning competitions, and it's spelled Kaggle. And if you Google Kaggle, you'll see it. There's constantly competitions, some sponsored by very large organizations with very large prizes. So.
Very large prizes.
Good incentive.
Nice. Another prize is please hashtag BPTN. It's a prize because we are here because some other folks hashtag BPTN last year, right? And so you definitely want folks to enjoy what you're enjoying, but at the same time to extend this community so that we can get more learning into it. You had mentioned at the intro that LayerSix is popular because of an Oscar for recommender systems. If you don't mind giving us a bit of a background and possibly some technicalities as well on that, how long did it take, and probably some challenges that you faced as well technically in executing.
I can share. The first time LayerSix won, I think it was just before the acquisition. I think the second one was post-acquisition, and when you have a team of talented individuals like this, you've got to create the space for folks to work on, initiatives like this. And I remember we were deep into a project, but we're also, we had folks working on the competition, and we really had to work together to make sure we created an environment where our teams could, we re-supported these other initiatives and, made sure that we put our best foot forward because it's something the whole organization can take pride in. Maybe, I don't know if Jonathan can share the secret sauce, but maybe he can probably share a little bit more of the, technical nature of the competition.
Yeah. The recommender systems is kind of the origin of LayerSix, and originally they were a company focused on recommender systems, and that was initially why TD Bank bought them as well, was they saw this benefit here, and the other benefits to the bank have grown since then, and in our retention of talent and our ability to grow a strong research organization within the bank. I was not on the initial RecSys teams, but I've been able to learn about the process because all the code is public and all the data is public too. So if you look for RecSys, RecSys, there's another competition happening this year. We'll see you there. And so basically recommender systems, what you're trying to do is often you're taking a pair of items. So you're looking at things like the second competition we did was Spotify recommending songs next. And so Spotify, I think uses actually the system we developed or parts of it. And you can see it anytime you go on a streaming platform. It looks at the users that are listening to songs, and it looks at the songs as items, and you try to determine which songs are ranked most highly for a certain user and which ones they might not have heard before, but that are very similar to the things that they enjoy. And then there's a lot of edge case problems around this, which is where kind of our machine learning platform came in really handy. And that's things like the cold start problem, when you have someone who's never listened to music before and you need to give them some sort of initial starting point that then leads to better recommendations along the line and things that they're actually going to listen to and click on, or however the system actually ends up working. So we built a very large platform around that then we were able to leverage later on within the bank, and was a big part of the acquisition as well.
Nice. Let's push through the slides to section 3 now, just talking a little bit about some of the challenges that have been faced regarding using ML in practice, right? Just provide us with some use cases and examples as we go along.
Yeah, I was going to say, just on the challenges side, and, one of the things that I would encourage everyone to really think about as you're starting down this journey, our experience was, this is new. It's really another layer on top of, you might be building applications, you might be building technology for various different use cases, and now you're applying, more of a complex model, that you're using the outcomes from a complex model that you may not have been doing before, because you may have been just coding, logic directly into your consuming applications. Now you're building a model that needs to run somewhere, and then there's outcomes from that feed those consuming applications. So architecturally, it could look very different, and it's something, you have to really think about. And that was a challenge that, we had to kind of navigate through. And even to this day, I mean, we're still kind of constantly reviewing and looking at the architecture. I think Jonathan and I just had a meeting, yesterday, just on this, kind of looking at our internal architecture. Something you definitely want to think about in terms of how it works, and how do you want the model applied? Does it need to be applied real time? Can it be run in a batch? Those types of things can really influence the broader technology ecosystem that needs to be built around what you're trying to do. And it's really important to understand those use cases early and think that through, and continue to refine that and think through, okay, where is this going to go next? Because it's a bigger change than just a change in the model. The power of the model is important, and it's an enabler, but it's everything else that's going to make you successful. So that's a challenge that we certainly face, and we have to climb that hurdle. For some of the initiatives that we've worked on with LayerSix, and certainly some of the broader initiatives that you guys have done in other areas of the organization as well.
Yeah, we look at the structure of the architecture and the organization, how we collaborate, and then we look at the outcomes of our models. And maybe I can just share 2 quick examples of what we've seen in the broader machine learning community of failures of our models, and some of the things that we keep in mind as we're developing our systems. So we had talked about fairness a bit earlier.
Yeah.
And there's these 2 examples that I heard a couple years ago from a really great professor of mine, Mimi Onuoha. She's our data researcher in New York, and she gave me these 2 examples. One is by an MIT graduate student, Joy Buluomi, on the left. You can see this photograph of her wearing a white mask and doing facial recognition. And this is a computer vision problem. We talked about using deep learning, similar to how at LayerSix we've done like pneumonia detection using computer vision. A lot of companies do facial recognition. And what they found was that often for certain people, like Joy, who's Black, the computer vision model just completely failed to detect her face. And she was very confused by this. And so she went out and bought a white mask and realized like, oh, she could complete her assignment when she wore this mask, but not when she had her real face. And so why did this happen? And she actually dug into it and found that a lot of the data sets that were used in public computer vision challenges caused the whole thing to be biased towards certain kinds of people. And so like often the original facial recognition data sets were significantly imbalanced towards male white people. And so there's been a lot of efforts in recent years to diversify those data sets, especially the public data sets that we're using, and to understand how we deal with imbalanced data. And maybe more on the like less deep learning side, there's this really good example of this thing called Compass recidivism data set, which we talk about a lot in machine learning fairness, which is where a machine learning model was used to predict the likelihood that someone would end up back in prison and when they were being put before the judge. And judges started using this to change the sentence, which was very problematic because there was a lot of bias in the data set where it would be much more likely to falsely recommend that someone was going to return to prison when they were Black versus when they were not. And it was much more likely to falsely recommend that they wouldn't go back to prison if they were white. And so these kinds of problems across many different attributes that we think about, age, gender, race, all of these can lead to huge problems in the model if it's unbalanced. And this is one of the reasons why I think it's really important to all of you guys that are considering how you want to be involved in AI research and in AI within your organizations, that you really bring your full self to the research that you're doing and the work that you're doing, because the models we're building affect everyone, but not everyone sees the negative effect. And so if you see it and you can do something to change it and to implement a lot of the mitigations and the new research that we're doing to improve the performance of models for everyone, then you can make a big difference in machine learning. It's still a very young field and there's a lot of room to grow, and I'm excited to see more people get into it.
Yeah, I would just add to that, we had to spend so much time learning, and, I just go back to knowledge is power, and we, even folks in our organization that weren't machine learning scientists, that didn't have this background, we really dug in. We wanted to learn about how does this work? How do some of these biases, these issues in fairness come about? And it's really, really important. That's why I love that we're doing this session, because it really allows us to go deep, and it's really important to kind of follow up and, learn about some of these issues and learn about, how we can apply these technologies, capability in the right way. And to us, it's just, without that, it's a non-starter. It's absolutely critical that we do that, and we make the right decision when we're applying some of these models.
Yeah, that's very great to hear. And, to your point, Jonathan, our involvement a lot more would help broaden the perspectives that we can provide to these systems, would help broaden the ingestion of data that they have, would help us get more involved in the learning and relearning that they perform to ensure that the level in terms of fairness is raised up, so that we are not having cases like you mentioned. Because, in the case of that kind of situation, you have someone who chose, on herself for Joy to really go after this. And she has a TED Talk, by the way, if you wanted to go check that out, on the same subject. And if you went to the next slide, you would see that we had some links shared. And there's also a link that's been sent by email to the folks in attendance. It's just a post survey on this exercise that we just conducted. We want your voice. We want to know what you thought about this, what you think we can improve on, what you think that would be the next steps for us, and also your general feedback on how these went. So I think that's been sent out, or will be sent out in the next couple of minutes to all of you folks. But going back again to the challenges and fairness, I think that's what's driving a lot of the interest in the field, and it's come on with a new space, which you just mentioned. And, you know, you are both excited about what the developments can be as we go ahead in this, and very welcoming to more perspectives, so that to ensure that, you know, TD and LayerSix are doing as much as they can to push the envelope to ensure that there's more fairness using these systems.
Absolutely. You know, I just want to say, you know, I know we're getting close to time, and, you know, first off, you know, I'm really happy to see the number of people that we have out watching this, and it just goes to show, you know, that you're taking the time to really go deep on some of these topics, and I think it's really, really important. We believe in AI first. We think AI first is where we're going. Our digital application certainly will be AI first. So as you said, Josh, it's coming. You know, there's no question about that from my perspective. And, you know, I would really encourage all of you to get engaged and learn as much as you can, because, you know, this thing is going to touch, you know, it's going to touch many aspects of our life.
Gotcha. So now we're having questions about follow-ups, and we're having more questions than we can answer in the time. In terms of how you can reach folks on this panel, everyone's names reflect their LinkedIn profiles as well. So Jonathan is Jonathan Smith on LinkedIn as well. Imran Khan is Imran Khan on LinkedIn as well. I'm Josh Iroko on LinkedIn as well. Feel free to reach out to continue the conversation. It's really critical that we don't stop here. Also, what you have on the slide, learn more. It's really critical for you to interact with these links, because when we continue the conversation, this is where we want to continue the conversation too. I've been officially told that I can announce the number of folks that we had, 137. It's amazing that you brought your lunch to your desk to look and interact with us during this exercise. This is terrific. We're meeting again on Feb 13th for the Black History Month event. I think it might be wait list right now, so you can join the wait list for that. And, you know, fingers crossed, you move from wait list to the actual list. And again, we have another session similar to this in terms of a masterclass next month, where we're talking a bit more about security regarding the development of systems that Uber currently uses. And because it's programming, it's going to cut across different fields. And you definitely want to know, how are you secure based on systems that are recommending things to you, based on systems that govern your transportation and manage your privacy of information. So definitely join that session. You definitely don't want to miss that. Imran, Jonathan, thank you so much for your time. Really appreciate it. This has been terrific.
Absolutely. Thank you, Josh.
Josh.
Thank you very much, everyone.